Students, our next topic is electric flux. Electric flux over an area in an electric field is a measure of number of electric field lines crossing this area. Electric flux over an area in an electric field. This is measure of number of electric field lines crossing this area. We know that number of electric field lines crossing a unit area. Number of electric field lines crossing a unit area means 1 centimeter square in CG system or 1 meter square in SI system. We know that number of electric field lines crossing a unit area normal to electric field at a point is measure of strength of electric field at that point, or it is a measure of electric field intensity at that point. Number of electric field lines crossing a unit area normal to electric field at a point is measure of strength of electric field at that point, or this is a measure of electric field intensity at that point. If we place a smaller planar element of area delta S, पहले तो एरिया एलिमेंट क्या था, यूनिट एरिया था 1 सेंटीमीटर स्क्वायर 1 स्क्वायर. अब क्या हो गया, इफ वी प्लेस ए स्मॉलर एरिया एलिमेंट of area delta S normal to electric field at that point, then number of electric field lines crossing this area element is proportional to E delta S. If we place a smaller planar element of area delta S normal to E at that point, then number of electric field lines crossing the area element is proportional to E delta S. It is not proper to say that electric field lines crossing is equal to E delta S, because number of electric field lines is a matter of how many field lines we choose to draw. What is physically significant is the relative number of magnetic field lines passing at different points of an area element. If we tilt the area element, for example, let us see that this is the area element, and number of electric field lines passing through this is represented by, or you may see that, आप इसको ऐसे समझें कि this is the area element and this is the number of electric field lines crossing. If we tilt the area element, number of electric field lines crossing this will be small, or you may say that if we tilt the area element by an angle theta, then number of electric field lines crossing this area element will be smaller. If we tilt the area element by an angle theta, or we may say that if we tilt the electric field through an angle theta, or we tilt electric field at an angle theta, then number of electric field lines crossing this area element will be smaller. Now here, as the projection of area element normal to electric field, as projection of area element normal to electric field is delta S cos theta, or projection of electric field normal to area element will be E cos theta. So here electric flux through this area element, here electric flux, which is represented by delta phi, electric flux through an area element delta S in electric field E is defined as delta phi is equal to E vector dot delta S vector, or E delta S cos theta. This is proportional to number of electric field lines crossing the area element. Here theta is the smaller angle between electric field and area element. Now delta phi is equal to E dot delta S is equal to E delta S cos theta. This may be written as E times delta S cos theta. This is equal to E times the component of electric field, or E times the component of area element normal to electric field. Electric flux may also be written as E delta S cos theta. This will be E cos theta into delta S. This is the component of electric field along normal to area element multiplied by magnitude of area element. Therefore electric flux through an area element delta S in electric field is defined as E dot delta S vector, or E delta S cos theta. We may write it as E into delta S cos theta, that is electric flux over an area element. This is product of magnitude of electric field and projection of area element normal to electric field, or this is component of electric field along normal to area element multiplied by magnitude of area element. When electric field is normal to area element, then theta is 0. Therefore delta phi, this will be E delta S cos theta is 0 आ जाएगा, cos 0 1 होता है तो E delta S हो जाएगा. This is maximum. When electric field is normal to area element, then electric flux through the area element is maximum. Second, when E is along the area element, when E is along the area element, that is theta is equal to 90 degree. Therefore delta phi will be E delta S cos 90 0 होता है तो सारा 0 हो जाएगा. Therefore electric flux through the area element is 0. Third, when theta is greater than 90, जब theta 90 से greater है, then cos theta is negative. Cos theta negative होगा, therefore delta phi is equal to E delta S cos theta. This will be negative. Electric flux will be negative. To calculate electric flux over a closed surface, we divide the closed surface into a large number of small area elements and calculate flux over. To calculate electric flux over a given surface or a closed surface, we divide that surface into a large number of small area elements. We calculate electric flux at each element and then add them with proper sign. Therefore electric flux will be E dot delta S vector and its summation. When delta S goes to 0, then summation can be replaced by integral. Summation को replace कर देंगे integral से and we get exact value of electric flux. We get exact value of electric flux. Therefore phi e will be this will be integral e dot ds, or this can be written as e ds cos theta. Therefore electric flux over an closed surface, this is the surface integral of electric field. This is the surface integral of electric field over the closed surface. Here circle over the integral sign, this represents that surface of integration is a closed surface. Therefore electric flux can be positive, negative or zero, depending on when theta is greater than when theta is less than 90, then cos theta is positive, so therefore electric flux will be positive. When theta is greater than 90, then cos theta is negative, therefore electric flux will be negative. And when theta is equal to 90, then cos 90 is 0, electric flux will be 0. Electric flux can be positive, negative or 0 depending upon whether theta is less than 90, theta is less than 90 degree, theta is greater than 90 degree, or theta is equal to 90 degree. Now electric flux is a scalar quantity. Electric flux is a scalar quantity, and its dimensional formula is phi is equal to e ds cos theta. Dimensions of electric field intensity is unit निकालेंगे पहले. Dimension unit of E is Newton per coulomb, unit of area is meter square, unit of cos theta is nothing, therefore this will be Newton meter square per coulomb. This is the unit. And dimensional formula हो जाएगा, न्यूटन फोर्स का होता है m1 L1t-2 अपॉन कूलम चार्ज का होता है a इंटू टी, मीटर स्क्वायर का l स्क्वायर हो जाएगा. तो ऑन सॉल्विंग दिस, इसको सॉल्व करने पर ये आ जाएगा m1 L3t-3 a-1. दिस इज द डायमेंशनल फार्मूला of electric